Okay, so if we're plugging in u of 0 and u of 3 here, what would u of 0 be? U is tangent, remember. So what is tangent of 0? Sine over cosine of 0 would be 0 over 1, which is 0. What is the tangent of pi over 3? And that was that's radical 3 over 1 half, which is radical 3. So these are going to be my new limits here. We're going to go from 0 to radical 3. We're just eliminating the need now for that tangent and all the trig period here. Okay, so what would the integral of u du be? How do we do definite integrals? We take the upper limit minus the lower limit, right? So what's the antiderivative of u? Yeah, u squared over 2. And then I'm just evaluating it from 0 to square root of 3. Okay. Remember, we don't need a plus c when it's a definite integral. This is all I have to do. Okay, so I'm going to take square root of 3 squared over 2, and then minus 0 squared over 2. So I get 3 halves minus 0. No plus c. On definite, the c's would cancel each other out. Okay, so my answer is 3 halves. That's it. Okay, and then we've got one more down here. Why did we change because if we plugged in the same things, we have to think about would that make sense if we did it the other way around. Let's think about what our derivative. Our antiderivative was u squared over 2. Okay, and then we can just change the limits right away. Now let's think if we change the u back to the tangent of x, would it work? So if we kept the limits but changed it back to the tangent of u, we would have tangent squared of u minus you have tangent squared of u over 2, right? And we would be evaluating this from 0 to pi over 3. Okay, so what would the tangent of pi over 3 be? We already said what that was, right? It was radical 3. So it'd be radical 3 squared over 2, which is 3 over 2. Okay, we get the same answer either way, but it saves us a step. Okay, we don't have to put the tangent. If we plug them in early, we plug them in when they're right here. Then we don't have to plug it in. We don't have to change it back and plug it in later on at the end. We don't have to go from u back to the tangent right there. Okay, so that's why we plug it in before we take the integral. All right, so now this one, we're starting from 0 to 1. What do you think my u and which one's going to be my du dx? Are we going to have to introduce anything? Let's think about this one. So what do we have to do here? And again, remember, where do we want the u, where do we want the du dx? We want the du dx to be on the bottom? No, we want it to be on the top. And does that look like a derivative? On the bottom, I have an x squared, so on the top, what would my derivative end up being? And x, right? X to the first. We're missing a number, but can't we account for that? We're basically just multiplying by 1 if we divide by the same number, right? So what number am I missing in the top? Missing a 2 in the top, because the derivative of the bottom, x squared minus 4, the derivative of that is just 2x. So we have the x, we need to account for the 2. So we're going to put that on the top. We'll just leave it on top. So I've got 2x over x squared minus 4, but we have to include a 1/2 of it. Okay? And then it's still the x. Right? So now I've got a u and a du dx, right? So what we already said it. What's going to be my u and which one's going to be my du dx? U is going to be x squared minus 4. U is going to be the entire body. U is x squared minus 4. And then the du dx is the 2x on top. Okay? And we're just going to ignore the 1/2. So I've got 1/2, and my limits didn't change here, right? So I go from 0 to 1. And now they're going to change because I've changed it to 1 over u du dx dx, right? And if you're going from this step to this step, step 1 here, step 2, do not put an equal sign. Okay? If we're not putting anything on the limits, they will count that wrong on the exam. Because it's technically not equivalent. Okay? It's not equal. The best thing you can do is just write an arrow. Okay? That's why when you guys get stuff, it looks like I've got a 7 on the one sometimes. Can I write it like that? I got into a habit of not writing equal sign when you get into the substitution. Just don't even write an equal sign. Just write an arrow. It'll keep you from being technically incorrect. Okay? It's easier that way. That way you don't get penalized for something as simple as putting an equal sign instead of just ignoring the equal sign. Hey,
I was confused when you do dx times dx. And what's du? Is it still 2x?
No, we're not worried. It doesn't matter what it is.
Oh,
It really doesn't matter. So we're not even looking at it as a number anymore. So I have 1/2 the integral of 1 over u du. We're not worried about du being a number. Du is just telling us what variable we're integrating with respect to. Okay. Now, what would my limits be? Because we weren't going from 0 to 1, right? But what do I have to do with my limits? I have to do u of 0 and u of 1 to get my new limits. So u of 0 is 0 minus 4 is negative 4. And then u of 1 is 1 minus 4 is negative 3. Okay, so I'm going from negative 4 to negative 3. Okay? Now, what is the integral or the antiderivative of 1 over u? That's the ln. Okay? So it's 1/2 ln of what? Absolute value of u. Okay? And then we need to evaluate this from negative 4 to negative 3. Now, this is why the absolute value is important. Is the natural log defined from negative 3 to negative 4 to negative 3? No, but if we plug in the absolute value, it's going to be defined. Okay? Because they're going to be positive numbers. So I'm going to have 1/2 ln of 3 minus ln of 4.
right? 1/2 stays on the outside.
Yeah, 1/2 is outside this entire thing. Okay? How could I simplify this? Does anybody ever know log rules? When I'm subtracting two things, it's 3 over 4, right? So I got the ln of 3 over 4. It's still 1/2 times that. What do I do with a number outside of or in front of a log?
Raise it.
We can go to the exponent. Okay, so I've got ln of 3/4 to the 1/2, or ln of the square root of 3/4. That's my exact. Okay, does that make sense? I know it's a little different when we're changing our limits there. Okay, but we have to recognize a main function is our u, and then we have to recognize a derivative of that function, which is the du dx. Okay? All right, there's a 7-2 day 2 math lab that you guys have to do tonight. You're welcome, Carson. I'll put it up right now. Still a quiet day without Panero.